Welcome to Natural Language Processing. This is a course taught at the University of Maryland. I'm Jordan Boyd Graber, and today we're going to introduce what we're going to talk about in this class and tell you about what it means to study natural language processing. And we'll get to know each other a little bit better. You'll get to know me through these videos, and I'll get to know you when we meet in class on the first day. First, let's talk about some of the things that you might have seen in the real world that use natural language processing. One of the examples that you may have in your own hand right at this very second is a smartphone, and you can ask your smartphone through the Google Assistant or Alexa or Siri a number of questions, and it sometimes can give you an answer. You can also go to Google Translate, type in a sentence in Chinese, and get a sometimes reasonable translation of that phrase. Another example is IBM's Watson, which went on Jeopardy and beat a number of smart people. We're going to see the kinds of technology that went into those applications, and you'll be building something very much like that by the end of the course. Another field that's associated with natural language processing is machine learning. And while natural language processing focuses on how we can get machines to understand natural languages like English, machine learning often talks about the tools that we'll use to accomplish this. And this includes things like techniques to understand language, classification. You may have heard the buzzword deep learning or neural networks. Those are some of the machine learning tools that we'll be using. But machine learning has been in the news recently quite a bit. We've seen Waymo cars take to the streets of Arizona, Top Go and chess players being defeated by algorithms, and this has been really impressive. We've seen superhuman performance by these algorithms. But the same thing isn't necessarily true when we look at natural language processing. But compare the experience of talking to a 5-year-old versus the last time you called an automated call center. And I think you'd be hard-pressed to call the ability of computers to understand language superhuman. So why are such great things happening in machine learning but not happening in natural language processing? That's one of the things that we'll talk about in this class. We'll uncover the very interesting reasons why natural language processing is so darn hard. But by the end of this class, even though natural language processing is very hard, you'll be able to see what we're able to do today, and that's pretty impressive, even though we're still far away from competing with humans on understanding language. Thus far, I've been dancing around what natural language processing actually means. So here's what I would say is the definition of natural language processing. Getting computers to understand, comprehend, process, and generate natural language. And natural language could be English, Chinese, German, a language that is spoken by human beings. And natural language processing is a very interesting field because it's intrinsically cross-disciplinary. Language is a part of the human experience, and language permeates all of academia. Just about every academic discipline uses language, sometimes supplemented by equations, to express their ideas. And so if you want to understand what it means to be human, you need to understand language. And as a result, language is deeply connected to understanding, say, the social experience of humans. A lot of our language comes out of social metaphors. If you want to understand how language came to be, you have to understand how language comes to be in human mind, and so this connects to psychology. If you want to understand how sound is produced in a human throat, this relates to physiology. And more directly related to this class, the techniques that we use in the modern era to understand language on a computer is closely related to statistics, it's closely related to mathematical understandings of information, and we'll use all of these tools to help computers understand language. And because this is a computer science class, we'll be using a lot of computer science algorithms like dynamic programming, and using hardware like graphics processors to create vector representations of language. So This course will touch on a lot of different areas. We'll talk about psychology, we'll talk about linguistics, we'll talk about computer hardware and computer algorithms. There's a lot of interesting stuff going on in this class. And we'll also be looking at data that tries to encompass all of human understanding. We'll be using repositories of human knowledge like Wikipedia that basically covers every field of thought and knowledge in the human canon. And the reason that we're going to try to process, say, all of Wikipedia and get computers to understand it is that at the end of this course we'll be building a question answering system. A system that can take questions and answer it. And this will require us to use a lot of different algorithms. We'll need information retrieval to find relevant texts in, say, Wikipedia that might answer our question. Given a question, we'll need to decide what it's asking about, whether it's asking for a human, a date, a title of a book. We'll need classifiers from machine learning to answer those questions. We'll need to be able to decide when our algorithm is confident enough to answer these questions. We'll need to use reinforcement learning and confidence estimation to understand that. And once we've gotten a bunch of possible relevant text, we'll need to extract the answer and build systems that can read the relevant Wikipedia pages to give a good answer to the question. And this corresponds to natural language understanding. So we'll be working on all of these things throughout this class, and at the end, you'll build a system that can compete with top humans at answering questions. And at various points in the class, we'll bring in some smart people who can answer questions on programs like, say, Jeopardy, to come in and see how well they do against your systems. So what do you need to do well in this class? You need to have some basic mathematics and programming backgrounds. In terms of mathematics, I'll expect you to be able to take derivatives. I'll expect you to be able to manipulate matrices and vectors. So multiply a matrix and a vector to know what it means when you have a dot product, things like that. I'll also expect you to be able to understand basic distributions. So if we have a multinomial distribution or a Gaussian distribution, you should know what it means to compute a probability from that distribution or what the parameters of that distribution are. If you're fuzzy on these concepts, on the course webpage there will be some refresher material so that you can get up to speed quickly. In terms of programming, I'll expect that you know how to program in Python. And we won't be doing anything too complicated in terms of Python programming, but you'll need to know how to create a class in Python, how to read list comprehensions and things like that in Python. If you're not comfortable with that, you'll need to get up to speed very quickly. We'll be using Unix-like environments for this class, so if you're not comfortable reading and writing files in a Unix-type environment, that's another thing that you should get up to speed on. Given that much of our class time will be hands-on, it's very helpful for you to bring a laptop to class, or if you're not able to do that, to make friends with someone who does have a laptop and buddy up with them. We'll be using the 3rd edition of the book Speech and Language Processing. It's a great book written by people who are either currently at or were formerly at the University of Colorado. It is the standard book for courses like this. However, the 3rd edition isn't out yet, so this is a picture of the 2nd edition right here. That's bad news in that you can't actually buy it at a bookstore, but it's good news in that the draft chapters are online for free at the moment, so you'll be able to read these materials online. The book isn't finished yet, so there are some chapters that are not available. For those chapters that are missing, I'll supplement that with other reading from the web. So, long story short, no textbook that you have to buy. All of our reading will be online. But if you want to buy the old 2nd edition of this book, you can probably find it relatively cheap, but the official thing that we'll be reading is the 3rd edition, which is not available in print yet. So to get ready for class, please make sure that you have Python and NLTK installed on your computer. We'll run through some mathematical and programming exercises to make sure that everybody's up to speed. And come to class with any questions that you have, and I'll also get to know you a little bit better. See you soon!